The Barton's pendulum experiment shown here is a beautiful demonstration of the phenomenon of resonance. Resonance is universal in nature. A child swinging on a swing uses resonance without realizing it. Modern MRI scanners use it to image the human body, and the color of objects as we see them depends upon the resonance between the light frequency and the atomic energy levels. In the experimental setup shown here, two oscillators of different frequencies are coupled to an array of oscillators via loaded strings. Each oscillator in the array has a different length and therefore oscillates at a slightly different frequency from the others. Although all the oscillators are coupled to the two main oscillators, the disturbance in the array occurs in two small regions alone, corresponding to the places where the frequency of an array oscillator matches with the frequency of one of the two main oscillators. The oscillators that are far away from the resonance frequency remain stationary and do not pick up any energy. This experimental setup can be used to explore different aspects of the phenomena of resonance in a physics laboratory. This is just one of the many brilliant experiments created by one of India's finest experimentalists.
The period after Indian independence witnessed a phase of aggressive nation building. Nehru's vision of a scientifically and technologically advanced India saw the setting up of large research institutions with state-of-the-art laboratories. The emphasis was on quality and meeting international standards in scientific research. But the question on everyone's mind was, where would the scientific personnel come from? This was a real concern. Science departments of universities, the breeding ground for future scientists, were struggling with falling standards of education, poorly equipped laboratories, and uninspired teaching methods. Into the setting came an experimenter scientist determined to change the way physics was taught in college and university laboratories in the country. Letting go of his job at one of India's most prestigious research institutions, he arrived at the University of Rajasthan in 1965 with a truckload of equipment and ideas. This is the story of Babu L Saraf, physicist, scientist, master experimenter.
बीआरसी में मैंने 10 बरस काम किया. तब तक मैं एक्सपेरिमेंटल वर्क ही करता रहा. मैंने 10 बरस में 3 पेपर 4 पेपर छापे वहाँ से. दे वर वेरी पुअर क्वालिटी वर्क. तो मैंने ये रियलाइज़ किया कि हिंदुस्तान में क्वालिटी का काम क्यों नहीं होता. उन दिनों में फिजिकल रिव्यू में कोई पेपर छापता नहीं था, एक्सपेरिमेंटल वर्क तो छपता नहीं था. तो मुझे ऐसा लगा कि मेरे को एजुकेशन में जाना चाहिए.
Dr. Homi Bhabha, then the head of BARC, understood the importance of scientists teaching in universities, and he supported Babu L Saraf's decision. But more unusually, he also gave him permission to take all his laboratory materials with him.
That is a unique example in the whole country, जबकि एक्सपेरिमेंटल वर्कर अपनी लेबोरेटरी को अपने साथ ले जाने के लिए दिया गया, नहीं तो वो वेस्ट जाती.
In 1965, Babu L Saraf joined the University of Rajasthan as Professor of Physics. He had completed his graduation from Jaipur in 1947 and was familiar with the city and its streets. His drive to revive the physics department brought new energy to the university.
Immediately, the first priority he did was to revise the labs. The nuclear physics experiments were put in. The electronics experiments were revived. In fact, the conventional tube electronics were just fading out and the transistors were on the scene. And as soon as I had done my MSc, I joined him as a research student. And the first task I did was to convert all pulse height analyzers, which were tube type, into the semiconductor analyzers.
ये सब सामान मैं बम्बई से लेके आया। जब मेरे बॉस ने कह दिया कि तुम सामान ले जा सकते हो, तो फिर मैंने वहाँ तबीयत से 4-6 महीने और छुट्टी बढ़ा करके लिया।
ये क्या
केमिकल्स हैं, डायोड्स हैं, अल्ट्रावायलेट लैंप्स हैं। एमएससी की लेबोरेटरी को भी खोल दिया, जैसा मैंने अभी खोला ना, ऐसे मेरे एमएससी के लड़के भी खोल सकते। तो मेरी लेबोरेटरी जो है वो यूनिक हो गई। ये सब टंगस्टन वायर है। लेबोरेटरी वर्क करने के अंदर समझ चाहिए और ये इन्वेंटरी बिल्टअप की ताकत चाहिए। अब इन्वेंटरी बिल्टअप में जो आदमी समझता है वो तो खरीद लेगा। इन लोगों को मज़ा आता है, जड़ से अलमारी खोल करके चीज़ें ले लेते हैं, पर जिन्होंने किया नहीं काम उनको क्या पता।
जुनून सा चढ़ा रहता था सराफ साहब को, काम के अलावा और कुछ ही नहीं दिखता था, क्योंकि उनको रात और दिन का कोई पता नहीं, खाने का कोई पता नहीं, कहाँ बैठे हैं उनका कोई पता नहीं। तो उनका एक आइडिया तो उनके दिमाग में रहता था, सामान जाते हैं, हाँ यार ये खरीद लाओ, ये भी ले आओ, ये भी ले आओ, एक नहीं 4 लाओ। कबाड़ी मार्केट है, वहाँ भी कई बार गए, सराफ साहब भी हमारे साथ जाते थे कि वहाँ जा कर के देखते थे भाई ये चीज़ अपने काम आ सकती है, यहाँ काम आ सकती है, ये नहीं मिल रही तो इसको यहाँ से ले लो। इनका एक काम है तो करना है, चाहे कुछ भी हो, उसके लिए कैसा भी काम करना पड़े।
मैंने एमएससी की सारी लेबोरेटरी को इंटीग्रेट कर दिया। मैंने कहा स्पेक्ट्रोस्कोपी की है तो एलिमेंट्री एक्सपेरिमेंट ये सब लड़कों को करना चाहिए, और न्यूक्लियर फिजिक्स के एक्सपेरिमेंट नए नए डिज़ाइन करके लगाए, तो लेबोरेटरी हमारी बहुत बढ़िया बन गई और नए नए एक्सपेरिमेंट हम बनाने लग गए। एक्सपेरिमेंटल वर्क में डेवलपमेंट किस तरह से होता है, तो इसका कोई जनरल प्रिंसिपल तो बताया नहीं जा सकता, क्योंकि कब क्या आइडिया आई, आपने क्या बदला क्या नहीं बदला, इट इज चांस। नॉर्मली आई हैव चोजन डिफिकल्टीज ऑफ माय स्टूडेंट डेज। व्हेन आई वाज अ स्टूडेंट, व्हाट वर द डिफिकल्टीज? नॉर्मली मुझे किसी ने आकर के नहीं कहा कि इसके लिए एक्सपेरिमेंट चाहिए, इसके लिए चाहिए।
Professor Saraf never underestimated the value of good technicians to his work. He built a talented team at Jaipur and created a work environment of trust and mutual respect.
उनका जो आइडिया है, उनको तो मालूम था इससे ये रीडिंग लेना है, ये साइंस का पार्ट है, वो हमें बताता था भाई इस प्रकार करो तो ये बन सकता है, इतना आइडिया वो दे देता था। फिर हम उसको उस लेवल में, उस एक्यूरेसी में लाने का हम कोशिश करता रहता था। उसमें जो भी कठिनाई आता था तो वो हम आपस में बैठ करके डिस्कस करता था, और इस प्रकार डेवलपमेंट का काम कंटिन्यूसली होते रहता था।
In 1969, Professor Saraf shared his ideas on physics education with Dr. Loganathan and persuaded him to come to Jaipur and help him to take his work further.
He had a clear idea that the purpose of physics education was not high technology, but rather getting the students to do something. Things should be visible. It should be as direct as possible, but at the same time, you should not sacrifice a quantitative measurement.
One of the oscillators in this experiment is driven by a feedback circuit and therefore oscillates perpetually without any loss of energy. A second oscillator is coupled to this driven oscillator via a string and mass arrangement. A lens is hung in the middle, with both the strings at an angle of 90 degrees to each other, so that there is no coupling between the oscillators caused by the lens. A lamp glows behind the lens, whose point-like image is displayed on a screen in front. The movement of the light spot on the screen is used to track the lens and is subjected to two perpendicular harmonic oscillations due to the two oscillators. In the beginning, when the driver is in continuous perpetual motion, the other oscillator responds to this motion because of the coupling, thereby picking up amplitude. At resonance, you see the spot on the screen moving in a circular path, indicating a phase difference of pi/2 between the two oscillators. In the off-resonance case, the second oscillator remains stationary, although the coupling is present and the driver is continuously oscillating.
Building upon the experience with coupled pendula which Professor Saraf gained, he moved on and started looking at the resonance phenomena between two oscillators, where one drives the other. This was the experiment for which he got an international award, and the citation actually mentioned that it was the simplicity of design which won him the prize. I would say that one should learn from this experiment and see how things can be built from simple objects and still one can explore fundamental laws of nature.
Babu L Saraf was born on 2nd December 1923 in Badnawar, a small town in Madhya Pradesh, not far from Vigyan and Indore. After school, Babu L Saraf's journey in search of knowledge took him to Agra University, where he did an MSc in physics in 1949. He married Vimla Saraf and moved to Delhi University. In 1952, he went to the Bartold Research Foundation in the United States of America. He also spent some time at the Nobel Institute of Physics in Stockholm. On his return to India in 1955, he joined the Atomic Energy Establishment in Bombay and was awarded a PhD degree in 1958 from Agra University for his work on electron capture decay. He stayed with the Atomic Energy Establishment, later known as the Bhabha Atomic Research Center, until 1965, when he returned to his university roots in Jaipur. In 1970, the University Grants Commission took notice of the amazing quality and range of educational material coming out of Professor Saraf's workshop and laboratories. The Commission gave Professor Saraf a generous grant and carte blanche to develop educational material for BSc level laboratories. Over the next few years, the Physics Department of Rajasthan University became the first and most valuable center for UGC's prestigious University Leadership Program. Numerous experiments were designed, fabricated, and supplied to colleges and universities. The innovative teaching methods and deep engagement with physics education that Professors Loganathan and Saraf brought to their classrooms and laboratories inspired a generation of young students.
He was unconventional. Specifically, for example, it would not go that his class starts with what is topic-wise on the prescribed syllabus. He would start with the topic, all right, but then immediately you see the generalization that comes into. He'll touch upon so many things which are not distinctly in the syllabus, but they are certainly useful, and you feel, yes, we are getting linked to the other dimensions.
Professor Saraf used to stress upon the basic ideas and the basic principles. And if your understanding is clear, then you can do any good quality work. So he used to stress upon the basics, do it yourself and verify yourself, do a quantitative measurement with best precision. You understand the error involved in different precision, you understand your instrument very well.
In 1983, Professor Saraf retired from the University of Rajasthan. But this was not the end of his career. He remained committed to the idea of promoting the use of experiments in physics education. With funding from the UGC, he set up an ambitious project in Ratlam, which worked closely with undergraduate level physics teachers and gave them the opportunity to use his experiments in their laboratories. The Holkar College of Science in Indore was an enthusiastic participant in the project and reported a very positive student response.
Actually, the study is always with the point of view of the examination. And so many finer details are not given that much importance. When one has to perform the experiment, then he comes across many problems and many questions. And he is doing the experiment for 3 or 4 hours and only thinking about that problem, that part of the theory, then he thinks deeply actually.
Professor Saraf was invited by Dr. Abdus Salam under the auspices of the Third World Academy of Sciences to travel to Africa and help local universities upgrade their laboratories and train their science teachers. A laboratory and workshop was set up at the University of Dar es Salaam, where over 100 teachers and technical staff from different African countries were trained.
अफ्रीका में कुछ टीचर्स थे, बहुत इंथ्यूजियास्टिकली सब एक्सपेरिमेंट को करते थे और डेटा वगैरह बताते थे कि इस तरह से हो रहा है, एंड बाय एंड लार्ज द रिस्पांस वाज अ सीरियस वन.
In the torsion wave setup, there are 2 vertical transmission lines. Each line is actually a separate apparatus. Each line is a steel tape loaded with dumbbells carrying weights. The line on the left has identical equally spaced dumbbells. The lower half of the line on the right has smaller dumbbells spaced farther apart, while the top half of the line has longer dumbbells which are closely spaced. Both the steel wires are fixed at the top, while the lower ends are free. The left line has an additional attachment which can be lowered in a bucket of water to vary the termination resistance on the free end. When the lines are not disturbed, all the dumbbells are in a plane. Let us start by twisting the lowest dumbbell and follow the motion of the wave towards the fixed dumbbell at the top. What do we see? We see that the sense of the twist flips upon reflection from the fixed end at the top. This is what is known in physics parlance as a phase change upon reflection. Now watch the wave move downwards and see it getting reflected from the lower free end. In this case, the sense of the twist does not flip. When a similar wave is started by twisting the lowest dumbbell on the right line, something interesting happens. When the upward wave reaches the point where the dumbbell size changes, part of the wave moves up, while a part of it gets reflected from this interface and moves back down. The wave moving up gets reflected from the fixed end, and the wave moving down gets reflected from the free end. When these waves again pass through the interface at the middle, they once again undergo a partial reflection and transmission. This demonstrates a general law of wave behavior at an interface. It explains why you see your hazy reflection in a window pane while still being able to see through it. All waves, be they of light or of sound, have this universal feature. This apparatus has been designed to match human scales. The waves propagate around 20 centimeters per second so that we can actually observe them.
The torsion wave apparatus of Professor Saraf is visually extremely appealing, and this cannot be by chance, it is actually by design. And therefore, one can use it as an example and look around in all his apparatuses. This aspect has been very carefully put in, the aesthetic aspect of Professor Saraf's work, where he has taken care that his apparatuses are actually like work of art. So they are a work of art in the sense that they look very nice, they are appealing, they can be used to demonstrate physical phenomena, and something which Professor Saraf thinks is the most important aspect of his apparatus, that you can use it to quantitatively verify laws of physics.
In 1994, the Indore Public School Academy invited Professor Saraf to spend his post-retirement years on their campus. The management gave him a basic staff and carte blanche to develop a laboratory, but did not burden him with teaching responsibilities.
यहाँ पर मैं जो कर रहा हूँ उसका local importance कुछ भी नहीं है. I should say I am like a कोई poet कवि है या कोई artist है, वो जो अपना काम करता रहता है, मुझे कोई पूछने वाला नहीं. मैं कोई 5,000, 10,000, 25,000 की कोई चीज़ खरीदता हूँ, वो खरीदने के लिए पैसा दे देते हैं. तो मैं अपने जो भी आइडिया मुझे सूझती है मैं कर देता हूँ. जैसे फॉर एग्जांपल यहाँ पर फोकस पेंडुलम लगाने की आइडिया हुई, तो मैंने कहा भाई मैं ऐसा कुछ करना चाहता हूँ, जो चाहो सो करो. ये गोला हमने हाथ से बनवाया, क्योंकि यहाँ कोई मशीन नहीं थी जो इस तरह का गोला बनाते थे. अमेरिकन्स 60 लाख रुपए में बेचते हैं, 60 लाख रुपया, और हमारे 60,000 भी खर्च नहीं हुआ है.
तो मुझे ऐसा लगता है कि इसकी जो ये asymmetry.
Far from retiring, Professor Saraf has gathered a new team in Indore to help him in his work.
वो एंगुलर मोमेंटम का मेजरमेंट है.
The teacher in him refuses to go away, and Professor Saraf continues to challenge and inspire students and teachers with his unique vision of physics education.
मैं अपनी लाइफ से सेटिस्फाइड हूँ. मैंने जो कुछ किया यूजफुल किया, उपयोगी किया. इनको आज समझ में नहीं आता है कि इसका उपयोग है, तो इट डज नॉट मैटर वेरी मच. वर्ल्ड क्लास में अगर आप मुझे कहीं रखो ना, तो आई डोंट स्टैंड. यहाँ पर चूँकि मैं थोड़े से फंडामेंटल समझता हूँ, इसलिए लोग यहाँ मुझसे डरते हैं. I live on my nuisance value. इस बात का I am proud कि जो फैसिलिटी मेरे पास थी उसका मैंने अच्छा उपयोग किया.